Hello, my name is Joanna Kulik, and in this video we will enhance the project we've done before to control the living room temperature and add the energy saving policy. As an outline, we will look again at the electronics that we need to use, and we will define a logic table for the energy saving policy. And finally, we will integrate this into the Blockly application in Livingroom Studio. So regarding the electronics, we have the same circuit. Basically, we have the heater that consists of a pack of resistors. And as we've said before, we added here an LED that shows us the intensity at which the heater acts. The heater is connected to the Raspberry Pi via a MOSFET. We have also a fan connected to the Raspberry Pi via a MOSFET. This is because these two require a higher voltage that the Raspberry Pi can provide. The fan is used to cool the living room. Then we have a servo, which is connected to the window, and we use it to open the windows in our intelligent house. And finally, we have the temperature sensor. We can also see the pins that these are connected to. Basically, for the heater, the servo, and the fan, we use PWM pins. And for the temperature sensor, which is a TMP36, we use an analog input pin. Now, we have the logic table that describes our energy saving policy. And here we need to take into account what is the most efficient out of the actuators we have. And the most efficient in terms of energy is to open the windows. So we want to use the windows as a means to set our temperature, that is to set the desired temperature. We want to use the windows as much as possible. Then the next in terms of energy saving is the fan, and the one that consumes the most, and which is represented in red, is the heater. And so basically we want to use the windows as much as possible and to keep the usage of the heater to the minimum. And we have the following temperatures that we read. We have the room temperature, the one that we read using the sensor. We have the ground temperature, which is fixed. We have the set point, which is the temperature set by the user and is the temperature that we want to have in our living room. And we have the outside temperature, which we will use a web service to measure it. Now, we can look at our logic table and we can see that we try to keep to a maximum the green lines. These are the lines where we use the window to control the temperature. Then we have some lines in yellow, which are the ones where we use the fan. And then we have those three lines in red, where we use the heater. We also have the lines in gray. These lines means that in these cases, we cannot control the temperature in the living room because the set point is below any temperature that we can control. And now starting from this logic table that gives us basically these states, we have to implement our application. When it comes to the application, we have four basic states that we need to define, and we use four functions for this. First of all, we have the function called off. In this case, all our actuators are basically turned off. So we have the windows closed, we have the fan turned off, and we have the heater turned off. It is important to keep in mind that in this example, we have no intermediate values. So in this example, we either have the fan turned off or on, and we have the heater turned off or on, because this would make the application more simple. Of course, you can add more complexity to your application and insert the error that we computed in the previous video. So for now, we just have the state yes or no for each of the actuators. So we have the off function. Further on, we have the function that controls the windows. The window function ensures that the fan and the heater are turned off and that the windows are open using the servo block. Next, we have the fan function, which ensures that the fan is turned on using the PWM block. It also uses the PWM block to turn the heater off, and it uses the servo block to close the windows. And finally, we have the heater function that starts the heater using the PWM block and sets it to a maximum. It also uses the PWM block to stop the fan, and it uses the servo block to close the window. So here we have the four states that we can use. Now we move to the actual temperature control, where we want to translate the table to the conditions that you can see here. And we have the controller function that controls the four states. So we translate the table to these conditions, and based on the table, we call one of the four functions that either turns off all the actuators or controls one of them. And it is important to keep in mind that we have four temperatures on which we base our table. We have R for room temperature, and this is the temperature that we read using the temperature sensor. In our example, we use constants for all the four. So we set the room temperature to 26. Then we have O for the outside temperature, which in our case we set it to 29. We have G for the ground temperature, which is also a constant. And we have S for set point. This is the temperature that the user will introduce as the temperature that they want to have in the living room. And now we introduce this whole in the application where we have a loop that keeps on reading the temperature coming from the sensor. We have the TMP36 sensor. And then we have the other three temperatures read on the serial port from the user. Basically, we want to read from the user the outside temperature, the ground temperature, and the set point. And once we have all these three temperatures, we call the controller function that will actuate accordingly. So in this application, we implemented an energy saving policy to control the temperature in the living room inside our intelligent house.